Hi, I hope you're doing very well. So, in this video, I'll try to demonstrate the Movio platform. Movio platform is a microservices platform. It has three services: Movio Auth service, Movio API service, and Movio Worker service. So Movio is basically a video on demand backend platform. If you see how the backend system powers a platform like YouTube or a platform like Netflix. So what I've tried to mimic their backend system. And what it does, Movio actually takes a MQB file. A user gives a MQB file, and the file should have a mm, subtitle embedded. The Movio extracts the subtitle, segments the video into MP4, and using a adaptive bitrate, then uploads all these segments in S3. It edits the manifest file, adds the subtitle information, and a CDN. I'm using a Gcore CDN. Using the Gcore CDN, the segments are actually being served, and that subtitle, which is actually uh, translated into 5 languages, is also served with that empty file. And I'm using AWS Lambda function to translate all these things. So the backend system is fully automated. There is nothing manual things to do. Once the user logs into the system, as long as he has a valid identity, um, and he just needs to a MKV file, uploads the video, and everything is processed background using a Celery. And I have built a very robust Celery pipeline that automates everything. So in this short video, I'll try to demonstrate the architecture. I will create another video where I will show you live how all these things are actually handling automated in Movio platform. So let's see the auth service. So this is the auth service. Auth service nothing fancy, just a English container. Yeah, so the full platform is Dockerized. There is nothing like it works on my machine. So this fully Dockerized solution. So it will work on your machine too. So no worries, as long as you have the environment variables. If we talk about the auth service is really very straightforward. There is a Nginx container running and a Django app and a Postgres database. So that's all, nothing fancy. You see. So next service we may see that, and you see that this is the standalone service. Okay, here you can see this is the standalone auth service. There is no dependency on the other services. So these three services comprises the overall Morpheus platform, but they are actually standalone service, and we can actually scale vertical at a stage. Then we can definitely scale horizontally to any service as you need, because we definitely need to scale worker service, because this is the worker service that is actually producing and processing too much of taking CPU power, processing the video. And when I show you the Celery pipeline, you will see that it undergoes a lot of things in the background. So we definitely need to scale the worker service. So this is why I have tried to decompose all these dependencies and their duties, and build services so that I can actually think of the scalability for the future. So this is the auth service I have already told you. Now go for the second service. What the second service does this is the API service. So API service is a bit messy. So let's see. This is the API service. This is the API service. You can see if we go to the source, and yeah, I'm actually currently building all the my Redmi files. So I need some time. Maybe by the time you will be watching this video, all the Redmi file will be generated. I will create a centralized Docker container, so centralized GitHub repo where all the information about all the services of the Movio will be here, and I'll be soon getting the file, README file. So what the API service does, if you go to the source and if you go to the YAML file, you can see there are several actually Docker containers actually running. So now let's understand what is actually happening here. So you see, this is the API service. If you see the overall high-level architecture, as usual, we see that this is the Nginx container. It is running on 8081. and it's forwards the request to the Boolean server, this app server of Django. And now this app server is actually our Django container is running two separate processes. One process for the Django main process itself, and another process for a Django management command. Then that management command is actually listening to this RabbitMQ events and publishing events to the RabbitMQ. So whenever a user actually sends a video, it actually processes the video, saves the video to the Postgres database, and it uploads uh, the stuff to Celery container. Yeah, Celery. So Celery does that it actually uploads the video to S3 AWS S3 storage, and it does several few things. And at the last stage, it actually mm, creates a message, creates an event to RabbitMQ solution to the cloud RabbitMQ instance I'm actually using. And for this publication, it is actually, and once the solution is published, this message is actually consumed by the worker service, and it has this message has some essential data so that the worker service can actually understand what needs to do and how the videos will be downloaded in that worker service to process the video. And it has, yeah, so it is about the uploading the video once the video is uploaded, and I am actually using a few AWS services, that is AWS Transcode. I am using AWS S3 and Lambda service. So I'll tell you, and here the flower is service that is used to monitor the Celery worker, and here I'm actually using Elasticsearch. So to search all these things inside the um, subtitle file or the video title or description, everything. I'm actually using a Elasticsearch. I have created uh, two database, and using the two database, I have indexed it in Elasticsearch, and everything the search is of the search of Movio is powered by Elasticsearch. And in to tell over the AWS, I am actually trying to make this video too much concise and not to make. So that's why I'm just going through the big picture. So I'm using a few AWS services, that is S3, to store all these videos and segments files and the subject files. I'm using AWS Translate service. I'm actually using Translate to translate the extracted subtitle into other languages, such as I'm translating the language into Bengali, Hindi, French, and Spanish. And to do this, I have made everything automated. And for this, I'm actually using a AWS Lambda service. In that Lambda, I have actually coded everything. And there, there the service is actually when anything even happens in the S3 bucket, the Lambda service take care of everything. It translates the original subtitle and it puts back to a designated other S3 bucket where all the MP file or where it will be serving as the upstream of the Gcore CDN, how the data will be delivered. So to be specific, API services actually what it does. It takes all these APIs. So you can directly interact with either auth service and either API service. You cannot directly interact with the worker service because worker service totally stays and remains in the background, like the backend devs. They do not get in touch with the other API exposures. So they are only accessible through the RabbitMQ events. So it API service for the upload API, it takes a video and it uploads the task to Celery worker. Celery worker uploads the video to S3 and it does some other essential perform a task. It creates an event to RabbitMQ instance and it's done. And this event will be consumed by the API worker service. So now we go to the worker service. Yeah, so this is the worker service pretty much same. It is also let's go to the worker service here. This is the worker service. Let's go to let's show you the YML file, and here you can see this is the actually how worker service is actually working here. So it is also pretty much same. But here, if I describe the worker service, it will take too much time because a lot of things are actually being happening in the worker service. But to tell you all the um, important things, what is happening once the API, it is also in the Django app, it is also creates two separate process, one for the Django app itself and another for the management command. The management command is actually listening to this cloud Rabingo instance, and whenever an event is actually created, it is actually a separate process. It is actually the management command. It is actually consuming that message, and this consumption is activates a robust Celery pipeline, and that pipeline goes sequentially. It actually downloads the video from S3, and everything is done by Celery worker, and nothing is done by the Django main process itself. So uh, it downloads the video from the S3 bucket. It then deletes the video from the S3 bucket. It's then actually, if I show you here, Movio worker service and go to source, and this is go to what? What is this? Go to core apps. What? Yeah, go to core apps, and yeah, go to MQ manager and go to, yeah, you can see from API service consumer. So it is actually consuming here, and you can see, oh sorry, this is a consumer. Yeah, this is a callback. So this is actually how it is actually listening. This is the Celery pipeline. So these are the tasks. It is actually it's chains a lot of tasks, a few tasks. Download video from S3, delete video from S3, extract CC from video, upload subtitles to translate Lambda. What it does, it uploads the video to a S3 bucket, and the Lambda function is actually now take care of the translation of the S3 subtitle, and um, and then it also upload to another designated S3 bucket from where this subtitle will be served. Transcode video. So it is an MKV file, and the dash player it cannot actually serve MKV segments. So what I'm doing here, that I'm actually transcoding the video into MP4, so that dash player can actually serve this video. And in adaptive bitrate. So what adaptive bitrate is that um, it transposes to different bitrate size. So if you know about the resolutions, so 360p, 480p, 720p, so it's segments or breaks down the video, whole video in different sizes. So whenever a user actually has a low network connection, the video quality automatically drops so that the user doesn't have to wait for what the video the user does not see any buffering or lagging things, so that whenever the network is strong, the dash player automatically pulls down the stronger or bigger segments file. And but whenever the network is actually low or poor, the dash player automatically dash player is too much intelligent, so it automatically downgrades the video, and it consumes the lower quality of video. So this is the adaptive bitrate. So I am actually transcoding the video in using adaptive bitrate. It is the MPV file is being transcoded to 360p, 480p, and 720p. So once the video is transcoded, then sorry, it transcoded. Sorry, I forgot. Transcoded mean I'm actually transcoding the MKV file into MP4 file. That is the transcode. I was explaining this their segments. So transcoding mean I'm actually transcoding or converting the format of the video from the MKV file to MP4 file, because unless I am actually first convert the video from MKV to MP4, I cannot actually segment. So what I'm doing here, first I'm actually converting the file format, the container format from MKB to MP4. Then I'm actually making the dash segments using adaptive bitrate of 360p, 480p, 720p, and the bitrate is 800 kbps, 1200 kbps, and 2400 kbps respectively. And in this dash segment video, you'll see when I show you live that there will be too much of segments, a lot of segments. So what I've done is that if I try to upload, because all the segments needs to be uploaded to the S3 bucket, right, for the to serve. to the audience. So if I rely on the single worker to upload the video, so maybe other worker will see title. So what I've done is that I'm actually making batches of 10 segments each, and I'm with 10 segments each, I'm creating another subtask of the Celery so that no user sits idle. Uh, because if I upload all the uploading tasks, let's say it has maybe 100 segments. So if I upload uploading tasks to a single worker, Celery worker, then maybe there are three or four other workers in the host system, so that time only one worker will be uploading, so the uploading process will be much slower. So what I'm actually making breaking down all the uploads into segments, sorry, into mm, a bucket or patches of 10 segments, then I'm actually getting subtask. So whenever a worker is actually free, then he can take that subtask immediately, so that all the segments is actually divided into 10 smaller sizes, and all the workers are uploading this video. So the uploading process is too much faster than just relying all the to give a single worker to upload all this mm, to S3. So here, this task is actually making another subtask. So it is actually batch processing those videos to upload to S3. Once it is done, what I'm doing, edit manifest file to add subtitle informations. So FFmpeg in general natively does not support to add the manifest file about the subtitle information. We can extract the um, subtitle from the using FFmpeg. It is very much easy, but we have to manually add the locations where we actually locations of where the subtitles are available. So what I'm doing here, that I am the manifest file that is generated by the dash images video, I am editing it. I am giving the proper location of the S3 bucket where the manifest segments file for this video is actually located, so that dash player can easily get that manifest subtitle files. And once this is done, then what I'm doing, upload dash segments to S3 and publish message callback. So this is a code, if you know Celery code. So what I'm doing, so it is actually it does a few other things. It uploads the manifest file, uploads the subtitles, manifest files, and it actually publishes a message to RabbitMQ instance that this for this video, for this user, this video has been processed, so that the API services actually can update its database to processing, a being processing to processing successful, or it can do some other tasks also. And then this task as a callback, it has a local file relation subtask. So when everything is done as a callback, the local file relation subtask is actually activated and it ends up the local storage. So this is the Celery pipeline. Yeah, there might be more three or four types of tasks, subtasks. These tasks are actually generating, so that kind of callback on some other ways. So to long story short, this worker service actually consumes from a API service. It downloads the video, it deletes the video from the S3, extracts the subtitle, then transcode the video to MP4, then it segments the video, it creates a batch processing of several other tasks, then it edits the manifest file to add about the subtitle information to the manifest file, and it uploads the all the segments and subtitles to a S3 bucket. Once an event is generated in the S3 bucket using .vtt format, a Lambda function is activated. That Lambda function gets the subtitle file. It uses AWS Translate service. It translates the video to the predefined languages I have already set: Bengali, Hindi, French, and Spanish. Then it takes all those five subtitles, original English subtitle, to another designated subtitle, that Lambda function, to another designated S3 bucket, where I'm actually telling the manifest file that here at this place it is the subtitles are located, and at last it actually creates an MQ event that this for this video and for this user, this video file is actually processing successful, and as a callback, the local file relation task is activated and all the local files is still out. So this is the worker file. This is actually what is this worker actually doing. So this worker is actually doing all this task actually. So this is actually the overall high level design of the Movio. So I will soon make a video to show you how things are actually working live. Thank you so much.